So for Android frontend, I'm going to use a project I created previously. I called it My App. If you want to see the details of how to create the app, please watch this video. But anyway, I'm just going to reuse some of the code that I created there. Basically, I do have a bare minimum application skin for the visual layer of the Android app. I have the main activity.java class that sort of acts as a control layer and a logical entry point into the app from a Java perspective. So I'm going to be using a Java wrapper. I'm going to wrap some logic in Java and call a Python module to implement the module. I have a script I call myhelper.py. I'm going to show you in a bit the code that is required to create a Python object and then make the appropriate call. But basically, once that call is made from Java into the Python script, and an appropriate function, the one that is going to make the REST API call to the backend, is called. Recall that in the backend we have the machine learning code implemented for linear regression. So once that call is made to the backend, the data will be fetched from the backend by the Python code in myhelper.py and then finally passed back to the Java class main activity here. So let's implement the Python module first. To begin with, we're going to make some essential imports. Requests. I'm going to use this request library for the REST API HTTPS implementation and the URL lib3 for support of REST API and URL interpretation. One thing to keep in mind is that we want to make sure that the build.gradle configuration has the entries to install our required Python libraries, URL lib3 and requests. I already have the entries here, but if you don't, please make sure to add them to the default config section and then down the Python pip configuration. Okay, back to the Python code. I'm going to implement a simple function. Define get predicted average daily dollars, or let's say daily earnings, because we're trying to predict the daily earning for a given average engagement rate. So all we're going to do here is that we're going to set up the URL, and remember the URL is laptopml.pythonanywhere.com. That's our base URL. So I'm going to copy that and paste it here, and then I'm going to define a session object. I'm using the requests library at this point to create my session, and then I'm going to set up some retry logic in case there is some timeout or there is some other issue. Then we're going to retry, and we're going to specify a count of 3 for the connect attempts with a backup factor of 0.5. We also need to define an HTTP adapter, so I'm going to instantiate the HTTP adapter with the max retry parameter set to the retry value that we have set up here. And there's some code required to indicate the type of HTTP we're using. We're using HTTPS, therefore we don't need the mounting for HTTP, but regardless, I'm just going to add it just in case we change our mind later and use a URL that is on the HTTP protocol instead of HTTPS. And then I'm going to set up the request object. And because this is a get call, we're going to map it to the get method, which accepts the URL and a few other related parameters. For the parameters, it would be where we map the request parameters in the URL. If you look at the base URL, this is the base URL, but remember that we can specify a user supplied value with the help of parameters. The parameter average underscore engagement here, so that parameter is what we need to specify. You're going to copy and you're going to specify that and provide a value. Let's just accept that value from the caller of the function. They're going to send a couple of print statements just to help us debug if something doesn't work as expected. Get request status code. This is nothing but the HTTP code returned by the get call. One more print statement. The text string that is returned by the get call in case it is successful. So that would be request.text, and then we should probably wrap the get call in a try catch block in case there is some exception thrown anywhere along the network layer or from the backend. So let's get some details about the exception itself. Let's define a flag variable. In case the get call succeeds, then we're going to set this to true, and if the status code is anything but HTTP 200, which means the call was not successful, then we want to return a special value NAN to indicate a valid value was not received from the REST API call. Else, I'm going to return request.text. So that's about as much as I need for now in my Python code. I'm going to go back to my Java code and create the suitable handler and the wrapper for the Python calls, and have to add code in the onCreate method. Okay, so the first thing to do would be to add the appropriate import, the appropriate Chaquopy packages so that we can create some Python objects. For the sake of better readability, I'm going to arrange them this way. Okay, with that out of the way, we're going to now create the Python starter code. I'm not going to go through the details of the starter code here. I've covered it in other videos. Next, we're going to create some Python objects as a handle to the Python module in myhelper.py. The module name is the same as myhelper because that's the name of my Python script as well. And then we're going to have to create an object that has a handle to the appropriate function call, and the Python function name is right here. I'm just going to copy that and paste that over here. And with all the declarations in place, we're going to make a call to the Python function get underscore predicted underscore average underscore daily underscore earnings. And we're going to print out the return value from the function call to the console. I'm invoking the call method in my Python object that points to this function. And because this function accepts this parameter average underscore eng, I'm going to have to pass that value right here. So let me declare an average engagement of some random value. Let's say, actually, I'm just going to keep it the same as here in the URL so that we can verify if the numbers do line up. So I'm just going to use 72.5. This is just a random value. So basically, when I make a call, the call method returns a value, and that value is supposed to be a string, which is the same as the text value returned by the REST API call to this URL. We expect that exact same string value to be printed to the console by the Java statement here. So That should help us verify that the data is traveling from the backend, which is where we have the Flask and Python implementation for the machine learning, through to the Python code that's making a REST call, and then back into the Java code. So some typos here and there. Okay, so there was an exception with our get call. The HTTPS connection was apparently refused, so what we're going to need is to add Android permissions to the manifest to access the network. To do that, go to Android view and open up Android manifest.xml and include the permission for internet access. Sorry, this is not what we need. We need the internet, and then I'm just going to copy a couple more to enter access network state and Wi-Fi state requests. And with those three permissions set up in the manifest file, I'm going to go back to my project view, close the Android manifest file, and then give it a retry. Okay, so looks like the GET request succeeded this time. Our GET request to the backend API succeeded with an HTTP status code 200. And therefore it got the text back with the prediction as expected. And then in Java code, we have the print statement here. The function call returns value, and it's right here in the log. The function calls return values, prediction for user supplied average engagement 72.5. Yes, it lines up exactly with what's returned by the REST API, the URL to the backend, and the machine learning processing that happened in the backend. So this verifies that the whole integration between Java, Python, and REST API with Python machine learning in the server side works. As I mentioned in the beginning of this video, our intent was to keep the model simple, to keep things easier on the machine learning side while focusing on the Python Java integration for Android. If you found this video helpful, please give it a like and share with your friends. Subscribe to our channel if you like content like this and more.